Hello, today we'll be looking at a worked example of the US concrete beam calculator. We will be designing to ACI 31814, and we will be looking at this textbook example that asks us to determine the design moment strength of the section shown below using a concrete strength of 5 KSI and a reinforcement strength of 60 KSI. So looking at this diagram, we can see that the total height of the beam is 22.5 inches plus an additional 3.5. The total width along the bottom is 14 inches. Our bottom tension bars will be 6 number 10 bars, and our top compression bars will be 3 number 8 bars. So let's input that in ClearCalcs. Our total height was 22.5 plus an additional 3.5 inches for a total of 26 inches. Our cross-section width was 14. The total length can be left at 30 feet as the length does not have an impact on the moment calculations. The concrete strength and the reinforcement strength are the same as in the textbook. So let's scroll down to the reinforcement cross-section. Let's define our bottom tension bars by having 3 number 10 and a second row of 3 number 10 bars to have a total of 6 bars. Scrolling down, we can define our top compression bars. We had 3 number 8 bars. And we can see that our reconfiguration of the reinforcement bars looks the same as in the textbook. So let's have a look below. It asks us whether or not we want to include stirrups. This was not present in the textbook example, so we're going to click no. Now, if we look at our positive moment capacity, it is 691,000 pounds-feet. If we scroll through the textbook example, past their intermediate steps, we can see that they had a final capacity of 675.9 kips-feet. So let's see what the differences in this example and ClearCalcs might have been. They have an effective depth to the top compressive bars of 2.5 inches, and to the bottom bars, they have 22.5. So in ClearCalcs, we have 2 inches and 22.7. So we can change the concrete cover. This is the distance from the concrete surface to the edge of the ties. So it has to be greater than 1.5 inches, and currently we're at 2. So let's change our cover to 2 inches so that our effective depth is now 2.5 inches. We said that our bottom depth, our depth to the bottom bars was 22.5 inches. So that is calculated by taking an average of our bottom bars. To achieve this, we can change this value to 21.6 inches, and that will match the 22.5 and the 2.5. If we scroll down, we can see all of the intermediate steps to calculate bending capacity. You can see that the neutral axis depth is 7.01 inches and that the strength reduction factor used is 0.9. Going back to the example, we can see that they determined the position of the neutral axis by balancing the tension and compression forces. They got a value of 7 inches, which is what was obtained in ClearCalcs. For their moment calculations, they also used a strength reduction factor of 0.9, and they got 675.9 kip-feet. ClearCalcs had obtained 676,000 pounds-feet, which is rounded to 3 significant digits and is exactly what we had obtained in the textbook.